This is a deep dive into the diameter-based protocol as defined by RFC 6733. And what it will cover is the domain knowledge, which happens to be telecommunications, the underlying technology choices that are being used, and this will be coupled by the implementation specific details, or you could say a discussion of how to implement some features that are defined in the standard. And I'll be presenting it. My name is M. Taha Masood, and I am involved in various kinds of work related to telecom and software for the last 20 plus years. So I look forward for you folks to view this. And please remember that this is just part one of a multi-part video lectures. Hi folks, welcome to this video. In this video, I'd do a walkthrough of the diameter-based protocol RFC. So what really is an RFC? RFC literally stands for request for comments, but you can think of it as a standard. Basically, it's a standard. Any RFC, it has multiple tracks, but for the sake of discussion, let's keep it easy. Let's say an RFC is the specification of a standard. And the RFC that we'd be going through today is the RFC that standardizes diameter-based protocol. So what is diameter? It's a protocol specified by the Internet Engineering Task Force, IETF, the great folks who gave us TCP/IP and related protocols. And the purpose of this protocol is AAA, which stands for Authentication, Authorization, and Accounting. In another video, we have briefly described this, and this particular video is going to be an in-depth, deep dive into the RFC itself. So let's start. So how do you view the RFC? So right now I've shared the screen of the RFC document, which is an open document. It's available on the internet on the website of IETF. And as you can see here, you can type this URL and you'll find this, or you can, do a Google search on diameter-based protocol, and that will be on the top. All right, so every RFC has a numeric code. This particular RFC has the code 6733. The code itself has no significance except that it's used for identification of a specific standard, right? I mean, there is no other encoding in that number. So one thing, less thing to worry about. With that, we come to the standard itself, and let's start reading it and let's start understanding it. But before that, instead of reading it from the internet on the browser, it's more convenient to download the PDF and view the PDF in a PDF viewer like Adobe Acrobat or other such programs, right? So I have downloaded this already with me, and I'll open that. All right. So let me open the PDF. All right. Okay. So it turns out I had actually not downloaded it. So let's download it again. All right. So here I go. Okay. So RFC 6733. And with that, I close this window. And It's just downloading it. Let's let it finish. So meanwhile, let's discuss why should you even listen to what I am saying? Well, I do know a thing or two about the diameter-based protocol. I have been the team lead who has implemented it in C, and we have done a very high performance implementation of the protocol, and we understand it in a lot of depth, right? So that is why you could learn a thing or two from me in that regard. So here we go. Let me open the file. It's downloaded now, and let us start. So I'll share the PDF screen. Here we go. So let's have more screen view. All right. So what really is diameter? And the way I'll be doing this is I'll be covering the important things, and where I feel that a further deep dive is not essential, and you have enough information to just look it up yourself, then I'll talk about it, but not go in depth. All right, so let's first see what really is diameter. What do these guys say in the abstract? So the diameter base protocol is intended to provide an authentication, authorization, and accounting framework for applications such as network access or IP mobility in both local and roaming situations, right? So it's a loaded term, but we'll break it down, don't worry. Okay, so this document specifies the message format, transport, error reporting, accounting, and security services used by all diameter applications. The diameter base protocol, as defined in this document, obsoletes RFC this 3588 and RFC 5719, and it must be supported by all new diameter implementations. All right, so let's take it one at a time. Network access means that there is the need, there is some device, right? There is some device, any device. It needs to access the network, any network, be it the telecom network or telecom network of any kind. There's some network, right? So to access that network, you can't just let any Tom, Dick, and Harry access your network, right? You need to establish the identity of the user. So hence, remember the authentication part of AAA, that is what comes into place here. And the second part is IP mobility. So IP mobility is basically utilizing the internet protocol to support the use cases that come into effect when the user agent, the end user typically is given mobile network service. When there is some aspect of mobility, be it uh, 3G user or a 4G user or a uh, literally any kind of uh, telecom network subscriber who has the in terms of the service that is afforded to the user, the service has a mobility angle. It is mobile. So typically think of it as for example, a 3G cell phone having a data plan. It's a mobile user, so that supports the support for IP. For that, we'll cover that later. So in both local and roaming situations. So this is local and roaming are the terms that come from the telecom perspective. A local user is the user where actually let me share a further screen to make things easier. Just give me a moment. We can do some quick definitions. Just a moment. So local user, basically, if we see this, so what is a local user? So typically what is a telecom network, right? So we have to understand that a telecom network is something like this. So here we have the end user. Here we have the access network, which is called the AN. Access network, typically you have transceivers, radio transceivers in a radio access network. And then you have what is called the core network, CN. So core network is the part of network which actually provides the core telecom services, for example, a call or a data plan or something. So the thing here is, the important thing over here to understand is that this part belongs to some telecom network. Let's say telecom op 1. Let's say it's an operator 1. So this guy A is the user of this telecom op 1 services, right? All right. So this is what is called, this A is a local user, right? So for example, you're a customer of Verizon or PTC or in United States or in Pakistan, uh, Telenor or Jazz or whatever. So there's some telecom operator and this guy is its local user. So let's say this is some country XYZ, let's say it's USA. And now let's say the telecom operator 1 has what is called a roaming agreement with another telecom operator, telecom op 2 in some other country, let's say Finland, right? So this is in blue, this is Finland. And we have similar kind of stuff over here as well. So maybe the local users over here, some guy B, there would be access network, the radio access network, some transceivers over here. And then there would be the core network of this network in Finland, so on and so forth. So exactly. So from the perspective of Telecom Op 2, this guy B is a local user, right? So let's say this guy A is traveling from United States to Finland. Let's say Telecom Op 1 has an agreement with Telecom Op 2. Such kinds of agreements are called roaming agreements. And this is typically very typical, you know, how things happen in the world of telecom. So let's say this guy A, he takes a flight, he lands in Helsinki in Finland, and he turns his telephone on, and bingo, they have a message from the telecom op 2 that, you know, welcome to Finland, welcome to Helsinki airport, and we are very glad to offer our services for you, being the roaming partners of telecom op 1. So from the perspective of this use case scenario, when A lands over here and is able to use the telecom services, A can be when so but remember this, when A is using the telecom services, he is using part of the network of telecom operator 2, right? There are some parts. Access network is definitely using some parts of core network. And then some part of that core network, what that will be is beyond the scope of this current discussion. But let's say some part of that core network will interact with the core network of this telecom op 1. So the thing is that this entire service is called roaming. And this subscriber A in Finland is called, or let's say, let's reword it. The telecom op 2 is the roaming area, you know, and this is called the home network. So actually, to be technically more precise, you can say that telecom op2 is actually a visited network. The service is roaming, but it's called the visited network. And over here, telecom op1 will be called as the home network, right? So it's very simple. The network to which you actually belong is your home network, the network which you are visiting, and which is enabling you to utilize the telecom services, even though you are formally speaking not their subscriber. That network is the visitor network, and this entire thing is called roaming. And of course, there is standardization, which dictates how exactly this is to work. Hence, roaming works. So that was a bit of perspective, and let's go back uh, to the other screen, right? So let me just close this and let me share back the screen again. So this is what we mean by local and roaming situations. So let's go down further. This was the abstract. So if we keep going down, this is all, um, for the sake of this discussion, technical deep dive, it's irrelevant. Let's keep going down. This is a table of contents. We'll talk about all of these in detail. Let's keep going down. Here we are. So this is the introduction. What does it say? Authentication, authorization, and accounting protocols such as this. Radius, the word diameter is a pun on radius. Radius was an earlier um, AAA protocol, very much in used in ISPs especially, and it's still in use, although the usage is gradually phasing out. So there were many lessons that were learned uh, from the operational perspective when radius was used in the industry. And many of those considerations have also been taken into account when the standard of diameter has been standardized. And terminal servers access. These are some examples, excuse me. Over time, AAA support was needed on many new access technologies, right? So what is an access technology? For access technology is the technology that enables the telecom user to access the services on the core network. So what could they be? They could be fiber to the home, they could be DSL, they could be 3G wireless telecom network, 4G wireless telecom network, etc. And the scale and complexity of AAA networks grew, and AAA was also used on new applications. For example, voice over IP. This has led to new demands on AAA protocols, right? So there has been a further, it's an older RFC which basically enlists the requirements that a good AAA protocol needs to fulfill, right? Um, it's let's forget that for now. All right, so let's quickly, however, I mean, we'll not go into that RFC, but let's quickly discuss this. So failover is very important. Diameter and telecom networks in general are very performance sensitive. You can't, when you are calling somebody for no good reason, your call cannot drop, right? You need 5 nines degree of availability. So availability can only be guaranteed if some kind of a failover um, support is there all across the chain, right? And we'll see that as we go in further depth. So failover, this older RFC does not define failover mechanisms, and as a result, this differs between implementations in order to provide well-defined failover behavior. This is the key. So if you intend to have a standard that interoperates well with between across different implementations, it has to be crisp. It has to be well-defined. So this failover behavior hence was very clearly and crisply defined in the diameter based protocol. So diameter supports application layer acknowledgements and defines failover algorithms and the associated state machine. We'll see this in detail, right? over here we are just um, going through the requirements that uh, the diameter standard had to fulfill, basically. So it helps when we'll do a further deep dive, it helps to know the context, to know what the requirements were and why, and how they were fulfilled, right? So the next thing is transmission level security. So Radius defines an application layer authentication and integrity scheme that is required only for use with response packets. So Radius, as you might remember, was an earlier old, um, basically older protocol. And this RFC defines an additional authentication, excuse me, and integrity mechanism. Use is only required during extensible authentication protocol. It's one of the authentication protocols sessions. While attribute hiding is supported, this RFC does not provide support for per packet confidentiality. It's very clear, packet level confidentiality is not required. In accounting, RFC just 2866 assumes. So assumes, remember, whenever you see the word assume in any standard, um, a red flag should really pop up somewhere that this is something which I need to be very careful about, and I need to be cautious, because an assumption is never a good thing in a standard. And if there is an assumption, the worst kind of assumption is one that is hidden, that is not clearly stated. And the next best thing is, the devil that you can live with is a clearly and crisply stated assumption, right? So if you are violating it, at least you should know. Assumes that replay protection is provided by the backend billing server rather than within the protocol itself. All right. So basically, replay protection is that, let's quickly see what is replay protection, right? So let me share another window, the whiteboard again, and we'll see what that is. So let's clear this first. All right. So what is replay protection? Let's say this is computer one, and this is some network. Let's say it's the internet or whatever, any network. And this is computer two, right? So let's say this is a request, or, let's make it simple. Let's say I'm sending some secret over here, right? Encoded as this string. This one has to send it to 2, and it's a secret, right? I mean, let's say on the basis of whatever is encoded in this message, the contents, let's say 2 has to make a decision. This is a decision point. Let's say if it's ABC, then do something, do 1. Let's say if it's, DEF, then do something else, do 2. Let's say this is it. Let's say I am actually sending ABC because I want this node over here being 1. I want this node to do 1, right? So I can tell it to do 1 by sending it ABC. Let's say there is some other node 3 over here, and it is sniffing the communication. And let's say it has captured this packet. It has stored this ABC somewhere locally. And I mean, this is an oversimplification, but you get the idea. Let's say if it has ABC over here, and let's say this node 3 now utilizing this network sends exact same message to 2. So by doing this, I would make 2 do something, which is this, because 2 would read the message, oh, ABC, okay, do this. So this is sniffing, and this kind of attack is called replay attack. So it's a very commonly used term in network security, and this is important. And this guy 3 in such kind of attacks is called man in the middle, right? This is a standard term over here, because hey, this 3 is man in the middle. Communication is between 1 and 2. They're doing some of their stuff, and this guy is just, a peeping tom and doing mischief. So this is also called a man in the middle attack. Replay attack is just one kind of man in the middle attack. All right, so why is this important in the case of diameter? I mean, why? Really, why is this important? It's important because in telecom networks, you are using some, there are other aspects too which we'll cover, but let's say at least one major reason is this. You're using some service. Let's say it's voice or data, whatever. There is some service which you're using. So a telco is not a charity organization, right? A telco will bill the user for the degree of usage that's being done, right? So you get the idea. If I can play a man in the middle attack and can provide false service usage info on behalf of some user to some billing node, charging billing node, then it's a problem, right? The guy is that whoever that unfortunate user is, they'll be deprived of their wallet amount in the, the amount that you have in your telecom subscription, the amount in your wallet, whereas you have not actually consumed the service, right? So this is in a sense what it is. So let's go back to the uh, earlier screen. So as you can see, security is very important in such scenarios. All right, so we move on. So while RFC 3162 defines the use of IPsec, so this is IPsec is a protocol which does the security part, the cryptography and stuff on the IP layer with radius. So this RFC defines that, okay, hey, you can use IPsec and all of the security issue is taken care of when you're using radius as a AAA protocol, right? Excuse me. Support for IPsec is not required. So pay attention to this word, not required. What does that mean? What that means is that if somebody wants, they can use IPsec, but it's not mandatory, right? It's not mandatory. All right. So somebody could be using this IPsec based cryptography based confidentiality enforcement, and somebody could choose not to. So it's not predictable, right? So lack of predictability is bad um, in itself, right? But in case of security aspects, it's very bad. So in order to provide universal support for transmission level security. So over here, by transmission level, it means you can think of as uh, the transmission layer, the OSI layers, the transmission layer protocols, for example, TCP, UDP, SCTP, etc. At that layer, you establish some security dimensions and enable both intra and inter-domain AAA deployments. All right. So this is a new term, domain. I'll explain that. Diameter provides support for TLS TCP. So TLS is a standardized protocol for doing the confidentiality stuff, the cryptography, security stuff on the transmission layer in association with TCP, and DTLS in case you are using the transport layer of SCTP, right? So further aspects of security are discussed in section 13. We'll see those as we deep dive further. But this context is very important to understand. Hence, I have spent some time over here. All right. So, what do we say? Yeah, there is this term domain. Let me just quickly tell you what it really means. All right. So, there are two terms that you would very commonly encounter over here, and they essentially mean the same thing. So, one term is domain, and the other term is realm, right? They essentially both they mean the same thing. When there are technical crisp differences, we'll cover those, but conceptually it's the same. What does that mean? It means an administrative crisp boundary, right? Administrative boundary, basically that's what it is. With clear ownership, and clear roles and definitions attached to that ownership, roles, and definitions of responsibilities. That is what it is. So what does it look like? Let's say this is somewhat abstract, right? What does it really look like? So let's take an example from another place. So let's say in case of another very familiar protocol that will help you understand. Let's say in case of HTTP, we'll have an HTTP client, whatever. So let's say you go to www dot, let's say any popular website, let's say cnn.com, right? So cnn.com is a domain, right? What does that mean? It's a domain. It means that it's clearly established who owns it, right? And what they can do with it. So behind that administrative domain name, which is www.cnn.com, there is a domain owner who has the privilege attached to do whatever it wants behind this domain, right? You could have a static web page behind cnn.com. You could have a great dynamic news website as it is, whatever. So think of it this way, right? This is an analogy. The roles are pretty much the same. With that, let's move back to the RFC. All right. So we'll actually do multiple sessions of this degree of depth cannot be covered in an 1 hour lecture. But for those of you who are actually, for the kind of audience that this lecture is intended, there is no other way to tell them what I'm telling, right? So, all right. So reliable transport is another requirement. Radius, remember the earlier protocol, it used to run over UDP and does not define retransmission behavior. So there is no UDP. If you remember, UDP is connectionless protocol, right? So basically, what does it mean? It gives you best effort, and then you don't know if the packet has reached its destination or not reached or got lost or whatever. So if you don't even, it does not even aim on the transport layer to have reliable packet or message, whatever you call delivery, guaranteed. If it's not even its objective, right? So there's no point of retransmission on that layer. Hence, UDP for good reason does not define retransmission behavior. Moreover, uh, Radius as an application layer protocol could choose to have a retransmission behavior of its own. Over on top of UDP, they could standardize if they chose to. They could have standardized some kind of a handshake, some kind of a protocol to um, to guarantee the delivery of whatever messages Radius has to send to its peers, basically. but they did not choose to do that crisply. So hence the reliability varies between implementations, and as described in RFC this 2975, this is a major issue in accounting, where packet loss may translate directly into revenue loss. So pay attention to this. Accounting is one of the key A's in AAA. There are three A's in AAA protocols. Accounting is one of those A's, right? And it happens after authorization is done. Um, Mostly there is credit control accounting as well, but we'll cover that later. The point here is that if you lose packets, then basically you lose revenue. As simple as that. So if I'm using a service, let's say I utilize 1 GB gigabyte of data from my data plan, and the associated accounting packet that had to tell the telecom network about this act of utilization of 1 GB by a certain user who happens to be me, if that information is lost, right, then the telecom network has just incurred a revenue loss, because then they will not deduct the associated relevant amount from my wallet. So see, this gets important. In order to provide well-defined transport behavior, diameter runs over reliable transport mechanisms. All right, so they chose to do the sensible thing, um, and they use reliable transport mechanisms. So there are reliable transport protocols out there, and so just why not use them? So there is some degree of trade-off between reliable transport delivery and unreliable, but it's beyond the scope of this lecture, but maybe we'll touch upon it later. But the point over here is that diameter runs over reliable transport mechanisms. So what does that mean? That means that when a diameter layer sends a message over to TCP or SCTP, these are the two supported transport protocols by diameter. What does that mean? What that means is that diameter can be content. Hey, this message will reach its destination. Either it will reach, or I'll be told that for whatever reason the message has failed to deliver after some number of retries, so on and so forth. So we move on further. Agent support, right? This is an important thing. Radius, the earlier protocol, does not provide the explicit support for agents. So what are the agents? It will become clear as we will do the deep dive further. But just bear with me. So what agents? Including proxies, redirects, and relays. So these are three different behaviors. And for now, you can just think agents are an agent could be a proxy, it could be a redirect agent, it could be a relay agent. What exactly that is, we'll cover that later. So since the expected behavior is not defined, it varies between implementations. So this is a big problem. If a behavior varies between implementations, so you cannot really interoperate well, right? And that's a big problem. So diameter defines agent behavior explicitly. Diameter does the right thing, and it crisply defines and standardizes what are the types of agents, what are their roles, what they can do, what they cannot do, so on and so forth. And that, of course, is described in this very document. All right. So with that, we move on to the next requirement, which is server initiated messages. All right. So while server initiated messages are defined in Radius, support is optional, right? There you go. If it's optional, it could be used, it could not be used, you could not depend on it. This makes it difficult to implement features such as unsolicited disconnect or reauthorization on demand across a heterogeneous deployment. All right, so that's a mouthful and I'll explain that. To address this issue, support for server initiated messages is mandatory in diameter, right? Okay, so the problem is these lines, and it's a mouthful, but we'll cover that. So, what kinds of features does it say are difficult to implement on account of lack of server initiated messages? Right? What are those? Unsolicited disconnect or reauthorization on demand. So these are the two features, right? So let's consider unsolicited disconnect. All right, what that is. Let's go back to the drawing board and see that. Okay, so let's say this is a AAA client, let's say. This node is a AAA client. All right, so typically such a client is embedded in some kind of another thing, which we'll just see. And let's say this is the network. And let's say you have what is called as the AAA server. So this guy is the AAA server. And so what is the role of a AAA client and what is the role of a AAA server? Let's say first we'll see the role of AAA client. The most important information with respect to the accounting part, right? Let's say we focus on accounting here, is to send service usage info. Basically, that's it, right? Let's focus on this. So what does that mean? What is a service usage info? So what does it? It could include things like, let's say, the number of megabytes used. It could, this is in case of data service, and let's say in case of voice, it could tell the number of seconds of voice that have been used, and to what are the called number, what is the callee number, these things. So this is, let's say, in case of data service, and this is in case of voice service. So this is the kind of information that is service usage information that is sent. And this is important, service usage information, right? So let's say, if you remember, I mentioned that a AAA accounting client is typically embedded into some other node. What that other node typically is, it is the node which is providing the service providing node, right? Or at least some part of the set of nodes which is providing the actual service. So examples, what could those be? In case of data, it could be some kind of an internet access gateway. You know, I need some kind of a gateway which connects the subscriber of the data, which is me, a subscriber. You know, hey, I'm on my mobile, I want to check the weather, with the backend, the core network, the part of the core network that actually connects to the great internet out there, right? So such a device is called the Internet Access Gateway. This provides data service, and in case of voice, it is some switch, right? It could be a traditional switch, it could be a soft switch, but it is a switch. All right. So the switch basically would provide voice service usage info. The data would provide the data service usage info. But from the perspective of a AAA client, it's only service usage info, right? And this service usage info in terms of some statistics, like this for data, this for voice, need to be sent over to some other node, which is called a AAA server, right? So a AAA server, what are its roles? So let's say, what do we expect of a AAA server? What does that need to do? Typically, what it needs to do is, let us pick another color, and let's choose this green color. Okay, so what are the roles of a AAA server? First role is rating, charging, and in some cases, authorization as well, right? So I'll explain that. That why do we consider authorization here? Aren't we talking about accounting, right? Aren't we beyond the phase of authorization? Don't we already know that this user, this subscriber, what is its identity? It has been identified, authenticated, authorized to use the service, whatever that service might be, voice or data, right? And that is correct. That is largely correct. However, there are some overlapping use cases which we'll see, where authorization uh, based on accounting data is needed. We'll see. So this is the role, and then integration with billing. So what do we mean by billing? Let's first close the chapter of billing and then we move further. All right, so what is billing? Let's say there is some billing node here. So the purpose of billing is to typically liaise with the upper hierarchies of the BSS software, which is business support system software. And some nodes could be CRM or self-service node. And we'll see how uh, how this pans. Oh, what happened? Just a minute. Okay. All right. Anyway, so billing is one role. So what is rating? Since we are over here, it's good to define what is rating. Rating is assigning, let's say, this is rating. And in basically, it answers a simple question. What is the monetary amount that I need to deduct against the amount of service that is used? What is the dollar amount, right? The dollar amount for service used. Service used. All right. So that is the question of rating. This is what rating answers. All right. So let's take a deep dive over here regarding rating. How can I really define or come up to that amount, right? So let's say we we do something else. We take this somewhere over here, right? So rating is dependent on two things. Rating depends on two factors. Number one is a tariff plan, right? So there is a telecom network and they are offering me some service. And of course, they're not a charity operation. So they would be advertising, they would be clearly telling me as a subscriber or a potential subscriber that what is the tariff plan that I'm subscribing to. We'll see that further too. And the second thing is resource usage, resource or service usage, right? So this aspect, the tariff plan does not change very often, right? You don't keep on changing your tariff plan every day or every second. So it's relatively less frequently changed. What are the kinds of things that it tells? So let's say $2 is the rate for 1 GB utilization. Let's say this could be my, and for every 1 GB after that, I'd be charged for every 1 GB after the first 1 GB, right? So let's say this is part of the data tariff plan. For voice, let's say a voice tariff plan could look like local calls are, let's say, 1 cent per minute. And let's say all international calls are $1 per minute, right? So this is a very simplistic data plan for voice. And this is a rather simplistic but tariff plan nevertheless for data. So rating is dependent on tariff plan, which contains things like these and which is advertised to the user. And the second thing rating is dependent on is the actual resource and service utilization. So where does this tariff plan come from? This comes from the CRM in the BSS node, right? Customer relationship management over here. This is the guy. And it could also come from other parts of BSS, like self-serving portal, whether it's some kind of a self-service, mechanism, where the user could, choose to um, select whatever tariff they want to subscribe, right? So think of it as this way, you go to your telecom operator given app and you can choose to switch your subscription plan, right? Or you can choose to subscribe to an offer, right? So you have a self-service portal or an app, or you could do that through SMS. Those are the channels that are there for the self-service, right? So self-service channels could be maybe SMS, maybe it could be an app, maybe it could be a web portal or any other channel, right? But it's self-service. The point is that the tariff information comes from CRM or self-service, and it does not change as often as the resource and service usage info. Now this is dynamic and this changes in real time, right? This changes in real time. What does that mean? What it means is, okay, I'm on my mobile and I have a data plan and I'm, downloading a very heavy file, a 10 GB file. So bytes are coming in, bytes are going out, and my data subscription is being consumed, right? So the operator really needs to know what is happening because they need to charge me for it. And how they'll do that is, in the case of data, there is some kind of an internet access gateway, which has some kind of a AAA accounting client associated with it. And together they send the service usage info, which in this case is bytes consumed, this guy, over to some AAA server, which does the rating, which tells me, okay, hey, this guy consumed 1 GB in 1 minute. What amount should I deduct from its wallet? All right, so what will it do? It will consult the tariff, the offers that the user is subscribed to, and it will come up with that dollar amount. And there you go. Charging is the act of actually deducting that amount basically from the wallet, right? Rating tells you the amount and you deduct it. That's charging. All right. So this context I feel was necessary to understand the context in which we are operating, the context in which a AAA service or a AAA protocol like Diameter operates. Uh, we have so far not discussed the authorization based on accounting. And this was actually the part that led us over here. So let's quickly discuss that. All right. So let's say we are talking about voice, or let's say data. Let's say there is a scenario where I have, let's say, 1 cent or let's say $1 in my wallet. I'm the user. And this is at point in time T0. Let's say there was some at some time I had $1 in my wallet that I maintained with the telecom operator. Let's say the tariff that I have is $2 per every uh, $2 per GB is a tariff, right? It's a flat tariff. I consume 1 GB, $2 are deducted, right? So let's say whatever the earlier pattern of usage was, at some point in time, I have $1 in my account and I'm still downloading a heavy file. So all of this thing goes on, goes on, goes on, and the AAA accounting client sends the service usage info. Let's say, now this is the interesting part. Typically, there is some frequency, there is something that triggers, it is a trigger. There is something that triggers the sending of the service usage info. It is typically either time based, which means that you could choose to do it every minute or every 3 minutes or every hour, time based frequency, or that trigger could be something else. It could be something more dynamic as well. To make the point, um, to put the point across, let's say it's time based. Let's say after every 1 minute, new service usage info needs to be sent all the way to the AAA server for a certain subscriber, some guy who's me over here, and I'm on my mobile, I'm downloading a very heavy file and I'm enjoying my life. All right. So let's say at time T0, when I have $1 in my account, till time T1, and let's say T1 is 1 minute, this delta of time is 1 minute, and let's say this frequency is also 1 minute. Let's say in this 1 minute, over here I have consumed 10 GB. I have already consumed it, right? Done. All right, so this information will be sent over at time T1 to this server. It will be rated. They will see, oh, okay, who's the guy? Okay, this is this user uh, X. Okay, let's see how much does this guy have. The rating will give the answer to the question how much to deduct. Remember, I utilized 10 GB. So as per my tariff plan, $2 per GB, the rating will tell, okay, deduct $5 from this guy's wallet. But hey, there's a problem. I only have $1. What do I do now? So there are choices which can be made basically. Typically, what I'll do is that, okay, I'll deduct this $1 and the delta of $4 is this user has to pay, right? Even though it has already consumed the service, right? Okay, now this brings us to this point, authorization based on accounting. But hey, I don't want this guy to keep on enjoying his life and keep on downloading further stuff. No, I don't want that. He has to pay for it. So I need a way to reject the service to undo the authorization that I had, that this user had, I need to have a way for that, right? So that way is typically a reauthorization. So I need to, let's say if such a scenario emerges, the AAA server needs to have some way to sort of asynchronously inform this guy, the AAA client, and through the AAA client to the node that is actually providing the service, that hey, stop providing the service to this guy. He has not paid. He does not have money and he cannot pay for it, right? That is called reauthorization. And one of the methods that is needed to do that is to send a server initiated disconnect message of sorts, right? And that is something that Radius did not have, and Dimeter has it. So it has very important monetary implications, as I just explained. So this is a big deal. All right. So with that, let's go back to the document that we were studying. This video has gone past its uh, life of 1 hour, and we'll continue it in further sessions. But let's revisit this term again in server initiated messages. Unsolicited disconnect, right? So unsolicited disconnect is, hey, the user does not want to disconnect. But I, as a telecom operator, as the AAA server, who knows that this guy does not even have the money to pay for the services he wants, right? So I'll send a disconnect message. Okay, hey, don't serve this particular user. All right. And it's reauthentication and reauthorization on demand is also one way. So with this, let me just, before I end it, let me just go back to that whiteboard again and tell one thing. All right, so one way is for the AAA server to asynchronously send a server initiated message. In that case, that's the best case, right? As soon as the event occurs, that is a risky event, that you open the window of the user consuming a service for which he's not paying, right? You want that window to be as narrow as possible. That is what is called real-time charging. All right. So the other way is to have it as a typically, let's say, in a typical client server protocol messaging fashion. Let's say a client sends something, a server sends something back. So if the server has to tell something to the client, it can only do it in the context of the response to a certain request, right? That is one way, but that increases the window of credit loss that can occur. We'll also cover this in further detail, but this basic context is important. So that is one way. And the other way is to get out of the paradigm of a strictly client server messaging. And whenever that event occurs, that can give a credit risk, right? Whenever that event occurs, then you send an asynchronous service initiated message, server initiated message. So Dimeter very much supports this. And with that, I'd like to uh, end this, and I'd like to let me just get back. All right, so here we go. So with this, the first part of this video, this lesson is over, and we'll continue this. And it's very likely that it will have 3 further sessions of 1 hour each with detailed, in-depth information of the domain of the technology from the implementer's perspective. How do you implement such a protocol? And also the business need. What problem are we trying to solve, right? Uh, Much of this part of the video, the lecture, covered the business aspect, the domain knowledge, because it was the context that was necessary. And as we move to the next part, we'll be covering more of the technology, but then again, we'll be doing back and forth with the requirements as well. That why are we choosing a certain technology or a certain technical way to do something, right? It has to have a context associated with it. And that context is the domain. All right. So have a good day. I hope you like this and have a good day. Bye. So hope you liked this. Please stay tuned. More parts are on their way. This was just part one of many, since we have to complete the entire RFC this way. And of course, there will be much more details. And by the end of this, in multiple parts, you'll have complete mastery over diameter protocol.